All right, let's try that. If that doesn't look good, we'll try something more. Okay, so welcome to Math 1206. It's Calculus 1, and unless you're a math minor or something like that, this is the calculus for general science majors. So if you're a business major or something else, and you don't intend to major in math or something like that, minor in math, you probably shouldn't be here. So I'm your instructor. We're spending a lot of time together throughout the semester. My name is Jhevon, and this is my email, which you will be able to contact me at throughout the semester. And that's jsmith06@fordham.edu. And yes, that is correct. I am the 306th J. Smith. Right? And you might also be interested to know that 306 is the number of 5-digit triangle numbers there, which I looked up to make myself feel special that I'm the 306th J. Smith. Okay, these are my office hours for the semester. This is my website. There are many like it, but this one is mine. And it will be very useful for you. So yes, lecture, that's me, Jhevon. It's not here, and I don't believe it's online, but this class has a recitation session, and Jason Gong, I believe, is running that. So you'll see him. So you're in section R04, so you're the second. I'm teaching 2 sections of this class. You're the bottom one, so you can circle that and scratch this one off. So Tuesday, Wednesday, Fridays at 1:30 in this room. Your recitation is actually in JMH, which is where the math department is located on the first floor. So Wednesdays at 10:30 in the morning, you should be in the other building, and you will be spending time with Jason. The website is super important, or it will be this semester, because I will be posting a lot of things here. So you can find an electronic version of the syllabus here. I would also post a link to these videos. I will also post things like reviews for tests, practice tests, quiz answers. Hey, and class handouts.
Blackboard's only to go to the other room.
Nice. Is your minoring in math too?
What's that?
You're minoring in math too?
No, I'm just
Are you sure you're in the right class?
Calc 1. Jhevon. Yes.
I mean, I know Diego's here and I had him for the
Finance?
same class, but a different section. Usually, you guys don't take this class, you take 1109 is the typical one, I think.
I made my schedule like 2 days ago. And
Yeah, you need to make sure you're in the right one.
Okay.
That's what I'm saying. So this is for science majors, not business majors. The Calc 1 for business is 1109. So double check with your guys around it.
Okay, sounds good.
Because this calculus is a lot harder than the other one. So you probably don't want to be here unless you really have to. I'm not trying to scare anybody, but it's harder than the other ones.
Okay.
This is calculus?
Yes, 1206.
Yeah.
Yeah, so lots of useful stuff. Right, so I'll be sending you there a lot, and you should be checking that website right away. Yeah. The textbook for the class, which you don't have to buy, but you probably should get your hands on one or be able to access one. If you go to the tutoring center, which I'll tell you where that is later, we do have copies of the textbook there. You might be able to borrow them from the library, but that's the textbook we'll be using. I'll talk a little bit more about how we're going to use that later on. This is the location of the math department, and that's the math department website. And pretty much what we're going to do today, we're going to go through the syllabus together, make sure we all know the rules of the class, set the mood, all that stuff. And you guys can stop me and ask me questions at any point. But essentially we're going to go through this and we are going to call it a day, and next time the real work begins. So this is the course description, pretty much a typical Calc 1 class, you can read that. Scientific calculators are allowed, but only scientific calculators. You won't be allowed to use graphing calculators or smartphones or any other electronic devices. But if you suck at arithmetic, you can bring a scientific calculator. This is the grading chart, how grades will be assigned based on what percentages you get. And that's the typical grading chart. You can find out more information about that by going to this link. And these links are all clickable if you go online, so if you're too lazy to type things out. The breakdown for how you will be assessed in this class is here, is as follows. So quizzes will account for 20% of your grade. You will have quizzes pretty much every week. I will be giving the quizzes in the recitation session, so we'll talk a little bit more about that. There's homework, which will be done online through web work. That's a free thing, so you don't have to pay for that either. Participation, I actually give you credit for showing up. You get 5% for attendance, but I guess I'll notice and you'll get brownie points for participating further. I like participation. I like having class talk back to me. So there's that grade. So show up, be on time. We have 2 tests throughout the semester. One will be during midterms week, and the last one will be very close to the last day of classes. The tests, the in-class tests, they're not cumulative, but we also have a final exam which is cumulative. So in terms of exams, there are 3, 2 in-class non-cumulative, and 1 final exam which covers the entire semester. And I'll talk a little bit more about that, but that's the overall breakdown. Moving on. Quizzes and homeworks do not have makeups. If you miss a quiz or you miss a homework, I'm just going to ignore it because I actually dropped the lowest 2 grades for your quizzes and homework, so that goes there. If you miss a test or an exam or a final, or you find out that you have to miss one, we'll try to work something out. You have to have a very compelling reason, but you should let me know as soon as possible. And again, attendance is super important. You can actually fail a class for not showing up often enough, so don't do that. Show up to class all the time, try to be early. Moving on. Work ethic, don't slack off, start working. You always say this. Everyone always waits until the first test and they're like, oh, I better start to pull up my bootstraps. No, don't wait that long. You only have 2 tests. There's a lot more pressure on than you would think. How many of you have taken calculus before? Okay. Good. Forget about it, right? As far as calculus is concerned, you know nothing, Jon Snow. Okay? Nothing. Okay? Because what happens is, a lot of times students who've taken calculus before, they kind of have this lax attitude toward the calculus. Oh, well, I've seen this before. And they always get in trouble with that. It is a trap. Calculus in college is not the same. I don't know why, I wish it was, but it's just not. So yeah, what you need for this class is really good algebra skills. If you had calculus before, that's great, but don't rely on that too much because you're going to be tested at a different level here. So I expect you to work very hard, work smart. I will be giving you advice throughout the semester about how to actually accomplish this, and I expect you not to slack off, start working day 1. In fact, your first quiz is tomorrow, and so we'll talk about that in a bit later. So yes, as far as that stuff is concerned, how I'm assessing you. Homework done through web work. It is not fully set up yet, but when it is set up, I will let you guys know either in class or through an email, and this would be the sequence of steps you go through to access the homework problems. Quizzes, again, they'll be done weekly in the recitation session, which again, notice it's a different location, and the format will be short answer, fill in the blank kind of thing, so not much partial credit there, but it's just making sure that you're keeping up with the material. And yeah, you'll be doing that in recitation. You'll also do your tests in recitation, but for tests you will be required to show all your work and you'll be giving partial credit, and I want to see everything. But for quizzes, I just want to be able to grade them quickly and give you like an overall view of where you are. So that's that. Final exam, also you have to show all your work. It's going to be twice the length of normal exam, so the test in class, we'll talk about when they will happen. will be about an hour long each. The final exam is about a 2-hour long exam. It will cover everything. The tests themselves do not cover everything. Put this paragraph in recently because a lot of students, another thing that freaks some students out, don't expect everything to be like exactly the same. Like different things in the class are meant to test you at different levels and help you along different levels of your journey. So if you do a homework problem and the quiz problem is slightly different, don't go, the homework is nothing like the quiz, this class sucks. It's not supposed to be like the quiz, right? Homework approaches you as if you're a noob. A quiz or a test doesn't, right? They're testing you at different levels. The levels of difficulty will vary, and they're kind of supposed to. So don't get bunched up on that. Again, prerequisites here, math is very cumulative. So you need to make sure that you're on the right foot starting out and stay on the right foot the whole time. And the right foot in this class starts with algebra. So be very good at algebra skills. In fact, tomorrow the quiz will be on algebra. Right? So I'm not really teaching anything today, but tomorrow's quiz will be on stuff that I kind of expect you to know already. Which maybe we can start talking about that. Yeah, let's talk about that a little bit. What do I expect you to know at this point? Hopefully I don't forget anything. Let's see. I expect you to know a lot about functions. What they are, definition, notations for them, representations. So if I write f of x, you should know what that means, etc. And their properties. Things like domain, range, etc. I expect you to know about familiar basic functions. So like, you should know what a polynomial is. You should know what a rational function is. You should know what a radical function is. You know what an exponential? Exponentials and logarithms I'll actually review in class with you, so maybe put a little asterisk there. Exponential and log functions. Polynomials, rationals, radicals, logarithms, exponents. Well, algebraic is a more general kind of function, but general functions. I do expect you to know how to graph some basic functions. Especially common ones like if I ask you y equals x, you should know what that looks like. Y equals x squared, y equals x cubed, y equals the square root of x, y equals 1 over x, y equals absolute value of x. Straight lines in general. Mx plus b, how to deal with quadratics, so this kind of function. So if I gave you a random one, for example, y equals x squared plus 5x plus 6, I expect you to know how to graph it, find its intercepts, complete the square, use quadratic formula. Talk about that, quadratic formula. How to factor, how to complete the square. Sketch. Random thing. And so how to apply transformations. So if you know how to sketch x squared, you should know how to sketch x minus 1 all squared plus 7. Like you shouldn't take too much time to do something like that. So I do expect you to know a lot about functions. at least at the level of algebra and pre-calculus. Anything else that I'm forgetting about functions? Yes, and know how to sketch them very quickly. That's going to be important later on. And so even while I was writing these down, you should have pictures popping up in your head as I'm writing these down. If you don't have a picture, that's probably not too great. You should know what these things look like by heart. What else? So you have to be very familiar with functions. We're going to work with them a lot. Next big thing, of course, algebra steps. So I expect you to know how to simplify and manipulate things. You should know how to factor things in general. You should know how to solve equations. So, for example, if I set this equal to 0, you should know how to solve that. Or the basic equations, polynomials, radical equations. You should understand how things work in general. Like, you can't randomly square something, but you can square both sides of an equation kind of thing. You should know that you can do one but not the other. What else? Oh, about functions, again, with algebra. Should know how to add, subtract, multiply, divide functions. You should know how to compose functions, find composite functions. That's something like f of g of x. Right, so if you have two functions, f of x and g of x, you should know how to compose them, how to plug one function into another, what that actually means. Yeah, so generally, algebra skills, know a lot about functions, know how to graph stuff, know how to simplify stuff, know how to solve equations, know how to use algebraic manipulations to get something in a nice form. What else? Yeah, that's just a quick overview. I expect you to know about trig functions as well. We will be talking about trig functions in this class. In the business calc, we wouldn't talk about trig functions, but here we'll do a lot with trig functions. So I expect you know the basics, the 6 basic ones: sine, cosine, tangent, cosecant, secant, cotant. What they look like, what are their values at special angles. So if I ask you, what is sine of pi over 2, you should know. What is cosine of pi over 6, you should know. Kind of know about the unit circle, that sort of thing. What else? If I remember anything, I'll tell you. But that's it. That's sort of basic level of knowledge from algebra. One thing, it's sometimes not only is it important to know things, it's important to know what things to avoid, what not to do. Which brings us to the next section. It's the section on blasphemies. So we'll talk about that a little bit. Anyone knows what the word blasphemy means? Yeah?
It means like when you speak out against a religion.
Yeah, it's a very inflammatory religious word, isn't it? It's like when you do something really, really bad, of course the consequences are really, really bad. And there are a few algebraic blasphemies that you don't want to do in this class, or the punishment will be very heavy. So you make one of these mistakes, I'll pretty much give you 0 for the problem that you make it in and just move on. I'm not going to read anything else you do. It's very important that you avoid certain mistakes. For example, let's just go through a couple of them so you can't be like, I didn't know this what you meant. Let's actually talk about them. One thing that you are not allowed to do not cancel across sums. It's very bad. students get into a lot of trouble for doing this. So if you're working on a problem and you get to a point where you got something like, say, 2x plus 1 all over 2, and you got, cancel the 2's. No, you cannot cancel the 2. That is super illegal. You cannot cancel the 2's here because there's a plus sign, right? This is called a sum. When you have things separated by pluses or minuses, you cannot cancel across them. You can only cancel across multiplication and division. So if you had 2x plus 1 over 2, bing, you're allowed to cancel that because there's a multiplication here. It's not, the terms are not separated by pluses or minus signs. Right? So you do not cancel across sums. Another thing that you should not do. Again, a very common mistake, but a very bad one, and causes a lot of grief. Do not distribute powers across sums. So, for example, you're working on a problem where I give you a problem and you see this expression x plus 2 all squared. And like, oh, well, that's just x squared plus 4, isn't it? Right? No, it's not x squared plus 4. That is incorrect. Right? You can't just take a square, put it on the x, and put it on the 2 and think that's the answer. Super illegal, super wrong, and I will punish you very heavily for it. What is x plus 2 all squared? Huh?
X squared plus 4x plus 4.
X squared plus 4x plus 4. Now there are a couple ways you could get to that. You could remember that this is actually that, and then you can FOIL, multiply out. You'll end up with 3 terms once you combine like terms. Kind of the rookie way, but it's not wrong. The nicer way would be to, you have a lot of nice formulas memorized. A squared plus 2ab plus b squared would be the one that applies here. It's the square of a binomial. So you should know that if I want to square this, it's this squared plus this times 2 plus that squared. It also works with the negative sign. What about something like this? A squared minus b squared. What do you think about when you see that? What is that? I say this is a formula. Complete the formula. Yeah?
Isn't it a plus b times a minus b?
Yep. This is a very famous formula. It's called the difference of two squares formula. There are a bunch of them, but difference of squares, you definitely should know that. Difference of cubes, it's very good if you know that. A minus b, a squared plus ab plus b squared. Notice there's no 2, a cube plus b cubed. You also have the sum of the cubes here. So there are formulas like that, but do not expect that you can just distribute a power across the sum. Another way in which this sneaks up on students is with radicals. So if you saw something like the square root of x squared plus 4, and you're like, oh, that's kind of annoying, let me just square root this and square root that. You cannot do that. That is illegal. Okay. Why is that illegal? Because radicals are really just powers in disguise, right? If I wanted to write the square root of x squared plus 4 using powers, how would I do that? Huh? What? I didn't hear. Yeah?
X squared plus 4 to the 1/2 power.
Right. The square root means a 1/2 power. So if you do this and you write that, what you're really saying is that, oh, I can take the half power and put on this and put on that. No, you can't. Very illegal, very bad. Okay? And in this case, it's not like that one where you're just missing like a middle term. To actually expand this to look something kind of like that, you'll need an infinite number of terms. Which when you get to Calc 2, you'll see how to do that. So yeah, you can't just because you have something really scary under a radical, you can't just get rid of the radical. There are certain ways you have to deal with things. So don't distribute powers across sums. This applies to radicals as well. Don't cancel across sums. Very illegal, very bad. Kind of weird, this one, but happens from time to time. Do not divide by 0. Right? Does not make any sense. You get to a point in a problem where you're tempted to write down something like, oh, 2 divided by 0, that's infinity, right? No, it's not infinity. 2 divided by 0 is meaningless. Division by 0 is algebraically meaningless. It doesn't mean anything. We will be covering a topic called limits, in which case we get super close to dividing by 0. So you can talk about, well, some of you might be familiar with this notation, but if not, don't worry about it. Where you can talk about something like this. So it's like you're saying the x is getting close to 0, and that might have meaning to you, right? But to actually divide by 0 itself is not possible. This one can be interpreted as, how would you interpret that for those of you who have taken calculus before? What's the answer here? Yeah?
Wouldn't it be 0? No, wait. No, infinity. Wait,
No.
positive.
This one actually does not exist. Okay? This one, almost the same, but I put a square here. This one is infinity. So when your denominator is going to 0, even small little things can make a big difference in the behavior. So you should just know there's no easy way to conceptualize division by 0. It varies on the situation, and when your denominator is approaching 0, getting close to it, a lot of crazy things can happen. You can get something that's completely meaningless, you can get infinity, but you can also get pretty much any other number there is. And so don't think of division by 0 as a thing. Like dividing by, 1 over 0 is infinity. No, it's not. 1 over 0 is gibberish. It's like, that's 1 over 0. Okay, can divide by 0, but when we get to limits, we'll talk about how to deal with situations where we're almost dividing by 0. Another thing, 4. This one is kind of in the affirmative. Not necessarily something not to do, but it's good practice. Use parentheses. Don't be lazy. You'd be surprised how many students get in trouble because they're too lazy to write everything down. So let me give you an example here. Or maybe let's actually work through an example. Let's see where our algebra skills are on the first day of class. Let's say I told you f of x is the function x squared plus 2x. And I asked you to compute this expression. What's this expression called? Yeah?
It's a derivative.
It's not the derivative. You need a limit attached to that to be a derivative. It's called the difference quotient. Okay? We'll talk about that a lot throughout the semester. It's a very important kind of expression. We'll see why. But let's say we wanted to compute this. How would we actually do it? What do I write here? Yeah?
You plug in f of x.
Yeah, tell me, what do I write?
You could do x squared plus 2x plus h. Minus parentheses x squared plus 2x.
Okay, so she got that parentheses. After the negative sign, you need those parentheses. I'll talk a little bit more about that. And you put that all over h. And that is not correct. Why is that not correct? Yeah.
You have to do x plus h squared plus 2x plus h.
Right. It's a very common mistake, don't feel too bad, but f of x plus h is not the same as f of x plus h, which is what you actually wrote down. You actually copied the function and then you added an h at the end. f of x plus h means something different. Whenever you have f and something is in the parentheses, it means you take that expression and you literally replace every instance of x in the function, right? This is creating a composite function. So the expression should actually look like this. So now here's what I'm talking about. So you might get this far, and they would neglect to write the parentheses down. Now, so I want you to be aware, don't be lazy, use the parentheses. A lot of times, students would not write it, and they'll say, oh, in my head, I know it's there. I know I have to do this, because you need the parentheses because that negative sign has to distribute to each term, right? And they might say, well, I know I should distribute it, but they don't actually physically write it down. What happens then is like 5 steps later, right? You're in a test, you're under pressure, I'm here like 5 minutes left, and you start freaking out. You're not going to remember that mental note of a parenthesis, right? You're gonna forget it, right? So be very careful, don't be lazy, write everything out, be very careful with your notation. If you're subtracting something with several terms in it, you need parentheses here. Do not neglect to write them and say, I know better. If you know better, do better. Put the parentheses there. It causes way too much heartache. Okay, how do we continue here? Well, it seems like we can cancel this h, right? No, that's cancel across. You do that, I give you 0. You cannot cancel that h. There are plus signs and minus signs. Okay, so what do I do? Yeah?
You'd first FOIL the x plus
Yeah.
h. Yeah.
So that's just x squared plus h squared?
No.
No. Do that, I give you 0. Okay. So what is it?
It's x squared plus 2x plus h squared.
Okay, that's the correct expression. This one? I'll just expand the parentheses here. This one, minus x squared minus 2x. Right? All over h. Okay, well now I can cancel this h here. No, you can't do that. Do that, I give you 0. It's so funny. Sometimes the student will go through like 9 steps, and on the 10th step they'd make that kind of mistake. Like, oh, come on, you're doing so well. Right, no, we still can't cancel yet because we have pluses and minuses separating terms. What can we do? Yeah.
Cancel the like times the x squared.
Cancel, yeah, x squared minus x squared dies. Plus 2x minus 2x. Forgot the parentheses, you'd end up with a 4x here when you shouldn't have. But now that's gone. So here I have 2xh plus h squared plus 2h all over h. And now we can cancel this h, right?
No.
No, you cannot cancel the h. There's still pluses and minus signs separating terms. So what can we do? Yeah?
You can divide up 1h.
Right, you can factor an h out. H is what we call a common term in the numerator. So we can pull a common h out. So this is one of the techniques from factoring. It's called GCF factoring. And so we're left with a 2x plus h plus 2 all over h. Now what? Now we can cancel the h because there's a multiplication. Right? Now for reasons that we will discuss later, when you're given a difference quotient and I ask you to simplify a difference quotient, the goal will always be to bring it to a point where you cancel that h. It's going to be very important that you cancel the denominator. So ultimately we'll end up with this guy, and that will be your answer. So that's the difference quotient for this function. Now, one thing you might notice is that when you know what not to do, as you might have noticed here, you kind of fall into the right way of doing something. You know, oh, I can't cancel. What can I do? Oh, can you move these powers here? No, I can't do that. What does that mean? What does this mean? You have to fall it out. You have to do this. Can't cancel. At any given time, knowing what not to do is kind of guiding you, right? So you want to know how to simplify things like that. That's important for algebra. But yes, you should be able to do things like this relatively quickly for this class and avoid very bad things like these last ones. Contact. So you have my email. I also have your emails. So I will be contacting you ever so often with advice or announcements or whatever. Maybe to send you your grades or something like that. So be sure to check your college email regularly. Feedback. I highly encourage feedback. So don't be afraid that I'm going to penalize you for criticizing me. That's fine. Just make it constructive. So don't be like, your teaching sucks! Your teaching sucks because you don't do this, you don't do that. I think it would be better if this is right. It does matter. I do take your comments seriously. I've been teaching for over 10 years, but I'm not a know-it-all. I don't know everything. So we're all in this together. We need to help each other out. So if you have any ideas about the class, you can let me know, and I will seriously consider them. Help. So if you do find you're in a situation that you do need help in this class, there are many resources here. I'm the first one. You can see me during office hours. Or email me and try to set up an appointment. The website will have a lot of materials on how to prepare for the class. So if you're getting help from me or help from anyone else, that should be kind of your first stop to see what you should be aiming for. Tutoring will be available in this room. I believe it starts next week, Tuesday or Wednesday. It's not up and running yet. But during the hours of 9 a.m. and 4:30 p.m. On weekdays, you will have a faculty member in this room at all points, and maybe one other tutor who can help you. So you can go there and ask questions and whatever. And even if you're outside those hours, a lot of the time the senior students hang out around there, and they'll be glad to help you with a calculus because they're there ripping out their hair on their homework. You know, they're in like their 3rd or 4th year and just dying. They'd be happy to, yes, I'll answer a Calc 1 question. Just let me escape from this for a little while. Do a difference. I'd love to simplify a difference quotient right now because this thing is killing me. So you can find a lot of help there. A lot of online resources. So there are math forums, YouTube, you can watch a bunch of other people. I don't care, I won't be offended. Khan Academy, Paul Online, lots of stuff. Wolfram Alpha, awesome website. Symbol Lab, also an awesome website. And you have a couple other resources here. Your classmates are also another resource. And so you should get the contact information of 1 or 2 people from class that you're missing class or you need to get notes or whatever, you can, or organize study groups, you can do that. If you think you may have a disability or you had accommodations in high school, you have to officially sign up with our disabilities office. You should do that within the first week of classes because to give you accommodations for anything, if you need them, I will have to have official documentation from this office. So you can find them here. Usual rules, no cell phones, no eating in class. You can have coffee, I guess, just remove your cups when you're done. Usual academic integrity policy, don't cheat. If I catch you, I have to do something about it. It's not going to be comfortable for anyone. I don't want to have the confrontation. Important dates. Just some of the more important ones, a more comprehensive calendar can be found here. And bringing us to the meat of the syllabus. So this is what we will be covering throughout the semester. You'll notice here, this I will do in class with you, reviews of exponents and logarithms, because while I kind of expect you to know about these already, some students aren't as familiar as they would be with functions. This you do on your own time, and I will test you on that on the quiz tomorrow as well. And then there are the rest of these topics. As you can see here, test 1 comes after topic number 15 is done. So it will cover all of these topics on the first test, which is roughly going to be around February 27th. Test 2 happens around May 1st. It is not cumulative. It will cover these sets of topics. So there won't be any overlap unless it's incidental. The final, though, will cover everything. As far as your finals go, currently, according to the current final exam schedule, these will be the dates. Do not travel on those dates, so expect to take your final on May 8th. Odds are it'll be in this same classroom. and it'll be during your usual lecture time. On the last page, there's a questionnaire I'd like you guys to fill out and detach and hand it to me before you're leaving. A few minutes to do that. In the meantime, are there any questions? Questions, concerns? If you came in late, make sure I get your name. What was? Did I get your name?
No, McAllister, you said?
Yes.
Thank you.
Oh,
Okay.
we'll see what Jeremy mentions. Oh, I want.
What's your name? What's your last name?
Yeah, and I do have it.
And I think I have.
Okay, thank you. Thank you.
So as I said, you'll have a quiz tomorrow on prerequisite material to cover like algebra and functions. Any other questions in the meantime? No? We'll see you tomorrow. Okay, yeah, we're done then.